Hello, geometry, and welcome to a full week of school. Now, that being said, I hope you all had a fantastic Thanksgiving break. This week, we're looking at rotating objects, so officially, rotations. Now, we're going to be exploring it mostly on the coordinate plane, so on a grid, but I will be demonstrating a little bit about how to do it off of a grid as well. Now, to start, let's go ahead and take a look at this web page here to kind of give us a ground about what rotations are. First things first, rotations are indeed turns or a spin, and they have to be around a center of some kind. And so, what are rotations? Rotations is a spin, and that center that I described about earlier has an academic name of around a center of rotation. Perfect. And so that center of rotation is what your shape is spinning around. And so here it is, looking at an example that's not on a coordinate grid. If you notice, this point A and the distance away it is from the 90 degrees stays the same as it rotates around to get to A prime. Remember, the primes are the image. Image is after the transformation. And so when we talk about a rotation, we're always referencing the size of the rotation based off of its degree measure. And so in this example has 90 degrees, but we could work with other degree measures as well for the size of our rotation. Now, if you notice, our shape does move position and it changes orientation. So here C was at top. Once we rotated 90 degrees, C is now on the bottom with A prime at top, where A was on the side before. And so the other two primary vocab words you're going to need to keep track of is clockwise and counterclockwise. If you don't know what that is right off the bat, make sure you have a clock on you. Clockwise is the direction a clock moves. So if you look at the top of a circle, when you go to the right, that's clockwise. When you go to the left, that's counterclockwise. And so here's some examples of spins, which is fantastic. And just as I mentioned before, clockwise from the top, moving to the right is clockwise. From the top, moving to the left is counterclockwise. Now, these are some fun shortcuts for how rotations work. I'm not going to go into those because they're incredibly narrow. Meaning when we look at applications of rotations in other contexts, even in this particular unit for this week, the rules don't always hold up in a way that's useful, as this requires you to know 3 different rules that only apply in one situation. And I want to give you some more generalized rules, so you have to memorize less. That being said, this web page is going to be available on our Canvas, so you can come back and refer to this to write it in your notes if you'd prefer, and use them if you think that's going to be helpful for you learning this content. So, ladies and gentlemen, let's go ahead and look at the next little bit here. So, referring to our second page here, we have ourselves another little bit of rotation knowledge from Math is Fun, and I guarantee you math is so much fun. Ladies and gentlemen, here we're talking a little bit about distances. And so if you notice, this image is being rotated around, but that point is staying on the circle. So we apply that to all 4 points, and they all create their own circles that are being rotated around. So, ladies and gentlemen, a circle is defined as all the points equidistant from its center. This center is the center of rotation. So the center of the circle that it makes is the center of rotation, and the distance from that center always stays the same. So a rotation transforms by points, and the points are always the same distance. I'm going to use some vocab and say the distance of those points is going to be preserved. And so here, like what they say, the distance from the center to any point stays the same. So the distance from the center to any point is preserved. But ladies and gentlemen, I do want to clear up one piece here, which is that notice as these points move, this one moved a short distance, this one moved an even shorter distance, but these out here move an exceptionally long distance along the circle. The further away from the center you are, the more your point moves in space. Even though they're always the same distance from the center, the actual distance it's moving changes based how close you are. Compare that with the translation we learned last week. A translation was always moving by the same amount, in the same direction, by the same distance. And so that's a good point, pun intended, to be paying attention to here, is that the distance from the center is preserved, but the points themselves move different distances. So the distances themselves are different, even though the distance from the center stays the same. So, ladies and gentlemen, here's another great example of a rotation happening without a coordinate grid as it gently spins. And here's an example with a triangle just gently spinning around in a circle. Now, ladies and gentlemen, here's a nice interactive that you can do for yourself. You can adjust the angle you want. Right now it's set to 70 degrees. You click the play button and it moves it point by point. And so here you go. Here's the example with all 4 points. It's rotating by different amounts depending how far away the points are from the center. And then they'll be rotated to the new points on the image. And ladies and gentlemen, that can change based off of where your center is. So here the center is at 0, 0. But if I take the center and I move it, over here, why not? Now when I go to do that rotation, it's no longer at 0, 0. It's going to be up here at 50, 60, or, 6, 5. And so all it's doing is the exact same thing we did before, but rotated to that new spot. So, ladies and gentlemen, as you do your rotations, pay attention to where your center is, and then you're counting and you're just rotating around whatever that center happens to be. So really you can ignore the grid and really just focus off of the distance from that center. Ladies and gentlemen, there's one last thing that I want to be able to focus on and help you guys out with, and that is going to use this last page here. Ladies and gentlemen, looking at it on a coordinate grid is going to be an easier way to say it than anything else. But if I rotate this triangle 90 degrees, there it goes. So here it is, rotated 90 degrees. And so notice the direction from our pre-image to our image was counterclockwise. So we call that positive. Counterclockwise rotations are positive. Ladies and gentlemen, this is our image down here. But if I rotate it in the other direction, so from 0 here, all the way around, it ends up in the same spot it was before. And it's the exact same spot. Now, ladies and gentlemen, here I rotated clockwise. Because of the fact that there's 360 degrees in a circle, a 90-degree rotation in one direction will always be the same as a 270-degree rotation in the other direction. So, ladies and gentlemen, a 90-degree rotation clockwise or counterclockwise, and that's what I'm abbreviating as CW or CCW as clockwise or counterclockwise, is a 270-degree rotation. The other direction. Which then takes me to the last point here, which is that if I rotate this 180 degrees, it does not matter which direction I rotated it. 180 degrees clockwise is the exact same thing as counterclockwise. So people will intentionally not tell you the direction when they tell you they've rotated 180 degrees. The other thing I want to point out is that 180 degrees rotation is not a reflection. Pay attention to how the points lined up. This point here in green does line up to the point that's farther away, but that's not because it was reflected, because the point in blue, if it was reflected, would be on this left-hand side of our image. And it's not, because when we did the rotation, it actually turned the shape so it's pointing in the other direction. So, ladies and gentlemen, I look forward to seeing you all in the next video. Take care.